Well, distributed isn't enough. We're going decentralized.
Ja, das machen wir mal ganz kurz. Hallo, ich bin der FX.
English.
English. Okay. The other German. Ja, ich stehe hier rum.
English.
Yeah, I'm here courtesy of the fact that I'm responsible for inventing the bullshit we're talking about, and funding the work on productizing it since forever. So, yeah.
And I'm making sure it happens.
Right. Here's the poor guy who needs to make it happen. History. Everything has a history. Part of the history just arrived. I spent 1.5 years of my life at a German venture, the toll road system, the electronic toll road system we have in Germany. And in this context, I was part of the security team, which at that time was pretty much only external people. And at some point, the responsible manager presented me with a heap of paper, an ISO standard 2828, and asked me for opinion. And I read it and had a couple of ideas, and then years of research happened. I got a bunch of people together that knew what they're doing and wanted to make this a reality, because as ISO standards go, people from the industry came together and basically wrote a big wish list, but nobody actually did it. And so this is the story about how we did it, and ta-da, there was a new PKI.
So, what is the basic idea behind 2828? It's independence from central CAs and connectivity as well. So, why? Well, size does matter, contrary to popular belief, because road networks are humongous. These are semi-actual data from last year. We have 13,000 kilometers of express roadways in Germany alone, and close to 700 more paved roads, and that is dwarfed by China, and China is growing quickly.
If she ever told you size doesn't matter, she lied.
Yeah. The thing is, your road network needs to cover your whole country, so it is a big-ass distributed system of roadside infrastructure. There's also a non-trivial number of moving targets, quite literally, because there's 50 million cars in Germany and 270 million in the USA, followed by almost as much in China. And for all these cars, you need efficient verification in maintenance scenarios, as in, who can update my firmware? And you need certificate management for vehicle-to-vehicle communications. So, making it more complicated, everything is federated. We as Germans are quite used to that. We have a multi-layer hierarchy. We have the EU, we have the federal state, we have our individual states, districts, municipalities, and you have, well, strategy happening usually on the higher layers that are a bit slower, but actual decisions that matter happen locally. So, we have lots of infrastructure in the field, and if you don't have infrastructure, that's it basically. This goes for everything, not just roads. So what's the most important part about your infrastructure? It's that, and that. So why then do we build our systems with single points of failure? I'm talking about those. by design, even if you have a CA that is by nature distributed, it still has central aspects. You can only check your OCSPs and CRLs if you're online. And the ISO standard wanted to fix exactly that. So now I've been talking about an automotive standard, but how does that apply to other industries? Because, well, we have lots of other industries. Automotive is just one. So every non-trivial PKI has the same problem. A push towards decentralization, exponential growth in permission levels, roles, and capabilities that you need to express. They all need to be resilient. And to be honest, all we really want is better failure modes. So let's look a bit at other industries. ICS and SCADA. I like my lights to be on and controlled by me, not by some involuntary Chinese guy. So yeah, what do we have? We have basically similar challenges. And if something's not resilient enough in SCADA, more often than not, it can go actual boom. So we have, for example, smart grid. What do you want? You want your power producers to allow the TSOs and DSOs that actually transport the power to trust them for something. You want the operations central to be trusted by the power generators to control the power generators. You want engineers to go into the field and do flexible maintenance scenarios to update your SCADA devices, even if they are offline. Then this also goes towards public transport and charging station networks, which are closely tied. And then over here, you come to the residential end of everything, where you have smart meters in homes. Moving to smart meters and or smart city and automotive applications. Here you have vehicle-to-vehicle communication. You have a growing number of autonomous driving and parking applications that are now upcoming, and you need flexible car sharing scenarios. That's the future. Here you have basically that again. You want cars to trust their drivers. You want drivers to be allowed to use autonomous parking. And you want cars to be able to use autonomous parking. At the same time, autonomous parking needs to be able to verify that you're allowed to be a customer because you're paying, and the car needs to be compatible with the technology used. Then we have that stuff. Here we have the special consideration that IoT devices that are targeting a consumer market are ridiculous device numbers. So the price pressure is very high, and you have very low performance platforms. What looks a bit better is smart home and building. There you need stuff like federated access control. You don't want to have one department that is taking care of your access cards for the building for all of your big company. That's what it is right now, but yeah, that also means you need 1 week head start to get new people on your campus. Looks like that. We have a smart home.
If you are lucky, try that at Microsoft.
You have a smart home where you can have some residential power generation, and you want to maybe allow your power grid operator to control parts of that, telling them, well, you can decide to put my solar panel on the grid, or have it instead put the power in my local battery backup. Then this nice thing comes around. The current push to IDAS, the new personal, the neue Personalausweis, the EU citizen card. The nifty thing is there is basically just a FIDO token on the NPA and the common EU citizen card. So you can use, if you really want to, I guess here nobody will, use your Personalausweis as a second factor for Facebook. Great. But if you have a common ID, you can do smart government applications, where you have the state trusting some tax accountant association to, well, name tax accountants. They name a tax accountant, and you can then verify that this is actually a tax accountant and delegate access to your bank account, read-only, to the tax accountant, flexible, using one system. So we want to tie that all together, because right now you have lots of islands and lots of nasty CAs. So basically one big system. But now you're saying, certificate authorities, we have X509, right? Yeah, about that. There's a little problem with X509. The thing that no one wants to talk about. If you want to revoke something, you need an OCSP or CRL. And if you need to revoke something, you're pruning the whole subtree of your hierarchy. Unrecoverable. Now, ask yourself one question.
The thing about CRL, certificate revocation list, is they don't.
Yeah. Ask yourself, is there any company that really fucked up their certificate authority that's still around or having customers? DigiNotar is dead, and even Symantec sold to DigiCert. I'm not sure why DigiCert was, yeah, I know why they paid 1 billion, because it's still a ridiculous money printing machine. We're selling random numbers, great. So, how is the standard going to save us? We want no shared overall infrastructure, and it needs to be easily integratable into existing systems. If you break one part, because let's be honest, it will happen, something will break, it's never allowed to take down everything.
It's an automotive industry standard. They're used to engineers at Audi, right? So they've foreseen the problem of someone probably fucking up.
Yeah. So they came up with, basically, that's straight from the standard. You have different security domains that are interconnected. Within the security domains in the standard, there's ISO 15764. But everything that's going beyond that, communication between security domains, is handled by 2828. It's based on a peer-to-peer approach. You have everyone talking to everyone else and verifying that, yes, I can actually talk to that device because I trust someone that knows that this is okay. And then you can establish direct trust.
This is what fascinated me about the standard when I first read it. It basically is, it is trying to model, or is quite good at doing that, modeling how humans trust each other, right? When you, for example, you join a group of people and then you ask someone that you begin to trust, who else here is trustworthy and for what, right? So.
Yeah, what it also needs is fine granular trust. With X509, you basically have certificate valid, certificate not valid, with some levels in between, like this is a CA and this is a leaf. But that's not enough if you have a very big system. You need, this one can read my registers, this one can read these registers, this one is allowed to do a firmware update, this one is allowed to reboot me. And you need to be able to delegate all of that, or part of it. And it needs to support federation, because that's what we already mentioned. So we came up with Trinity.
Trinity background is, when I read the standard, I realized this is awesome because it would nuke all the certificate authorities. So hence the name. Trinity was originally the code name of a bunch of geeks in the desert building Fat Man, the first nuclear bomb. And yeah, this is where the name comes from.
Yeah, so what do we have? We have a PKI, basically, that is fully transport agnostic. It doesn't matter where you put your delegation data. It just can be communicated to everyone, by everyone. You can basically quote everyone, because it's all signed data. So you're no longer reliable on OCSP or CRL servers that are specifically named. Also, we came up with a concept called trust policy languages to express arbitrary permissions, roles, and capabilities at arbitrary precision and make them subdividable. Also, this is the nice part, it's extensible in the field, so you do not need to roll out a firmware update if you've designed your trust policy language right. And it can be mathematically proven to always parse correct. It is fully offline capable. Everything is verifiable offline, and it is designed to enable store and forward networking. We'll get to that. So let's look at a practical example. How would toll collect operate if we had Trinity back when Felix got the standard the first time?
Yeah, so this is how the problem space works. To give you just an impression of how toll collect operates, it is basically a zoo of keys, cryptographic keys, symmetric keys, that is, because if it were asymmetric, it would be a turtle zoo, and that's not helpful. One problem in this space you've probably seen if you've been on the Autobahn. In toll collect speech, that is the ConAU, Kontrolle automatisch, right? Or as common people call it, Mautbrücke. And how does that work? This gentleman and I had the pleasure of scrambling around those a couple of times. So basically what it does is DSRC, which is data short range communication, which is basically the wireless serial between the truck and the bridge, right? So when the truck goes through under the bridge, it actually talks wireless serial to up.
Keep talking.
So the bridge actually has a cable to the back end, basically talks to the infrastructure. And there is, I said, there's a zoo of keys. So every vehicle has its own key on a chip card in the device. That thing is, for the Germans, we like to invent interesting terms. That thing is called Erhebungskarte. So the threat actors in this scenario, this is what surprised us when we worked there. The physical attacks on those Konnaus on the Mautbrücken happened very, very obviously close to the Polish border. Because guess what? People that are shipping truckloads of illegal immigrants from Poland to Western Europe don't fucking like their trucks to be photographed. And the non-obvious threat actors, the first one obviously is time. Very much like for us here right now. There is time coming. So if certificates expire, it sucks. So you have to renew them. The other non-obvious threat actor is the great equalizer of the tech in the field, the plow. So since those ConAUs are somewhere out in the country, there is cables going through the fields next to it, and if the Bauer happily goes and plows his field, then suddenly the bridge goes dark.
Okay, so how does that look in practice? First of all, we have a trust overlay network. We have the big cash register that is called toll collect. We have two ConAUs and a truck going between them. The ConAU is trusting the big cash register to tell it everything that's regarded to toll paid. And the cash register then said, well, this truck paid, so this one with a very obvious license plate has paid. The other way around, the truck is trusting the cash register to, well, basically trust them to tell that this is actually a valid ConAU that I'm talking to. And then we have a trust edge going back to the ConAU that says, well, this is a specific ConAU. Communication happens over the internet, rah-rah. That is very complicated. We have here arbitrary exchange of data over the white edges and then trust-verified communication over the black edges. Now, we have adversarial conditions, and we need graceful degradation to store and forward networking. Trust, again, in that scenario is exactly the same, but there was the plow, and it equalized the internet connection to that ConAU, and here we also have a mobile phone outage, because we know German Autobahn, there is no good mobile coverage. So if something changes now, how do you get the information to that ConAU? The idea is TC publishes updated trust and pushes that to one ConAU that is downstream on the Autobahn or upstream, depending on the way you're driving. That is then loaded in a drive-by to whatever truck is passing underneath, which is perfectly fine because we're transport agnostic. We don't care if it's a direct cable connection, if it's verified, if it's a Russian business network, no one cares. The truck then passes underneath the next ConAU, and it dynamically deposits whatever trust it got from the first ConAU to the next one. And that way you can progressively still keep your system running, even though it doesn't have any network connection.
And it doesn't need a trusted network connection. So if the truck happens to be a Russian truck, it doesn't matter because either it has 80 tons of computing center on it, then it can happily try to break the encryption keys, but it is very unlikely to succeed until it hits the next ConAU, right?
Yeah. And why does this actually work? All trust that we delegate within our system is packed into a CRDT, a conflict-free replicated data type. That means wherever I get it from, whether I had a net split or several that were merged at whatever point in time, I can always decide which information from any node is the newest and thereby most relevant. We also don't have explicit revocations. We simply change our mind and publish a new state of trust, and the newest wins. Also, delegation updates are atomic. There is no such foot cannon as accidentally first revoking all your certificates and then trying to roll out new ones. Sol Collect learned the hard way, this doesn't work. So what's it actually good for beside that? Well, you can do decentralized mesh VPN with delegation. So you do not have to name every participant explicitly. We actually have a quick white paper on our website on that. You can do globally delegatable single sign-on, and not just for applications, for everything. You can delegate access to buildings, legal services, public transport, whatever you want. You can do threat intel sharing. You can very specifically name what someone can see, what you're sharing. You can classify your data all within that one system. You can do change management. You have perfect traceability. You know at every point of verification over which edge and delegation you came to this decision. So what would the world look like if revocation day comes around and we had PKI? Probably like this.
Again, trust like it works with humans. Revocation happened, and basically, how does revocation work with humans? Someone tells you, I don't trust this guy anymore. And that was it. You might spread the news to your friends, but it's more or less like this. There is no CRL involved. Does anyone here have a CRL with their friends with them?
That's it for us. Thank you. If you have any questions, we'll be at the dinner. Hit us up. If you think that anything we told you does not work, I want to hear your scenario and discuss it with you, definitely. If you think it will work, talk with me. That makes the conversation easier. And yeah, we'll be around. We're here tomorrow and the day after tomorrow as well. Thank you.